Good morning again, young people. Let's talk about a full-blown three-step stoichiometry mole problem. Here's an example. 2 KClO3 yields 2 KCl plus 3 O2. If 5.0 grams, that looks to me like a given, so I'm going to go ahead and put my highlight there. And remember, I get the number and the unit. And I'm also looking for a chemical, and here it is, potassium chlorate, KClO3, are decomposed. How many liters, there's my unit, of oxygen gas, there's my chemical, are produced at STP? Now, one of the things you'll notice here is that we have a reaction equation, so we know we're going to need to use a mole-mole relationship, a mole ratio. You'll also notice that we have grams of one chemical, and we have liters of a different chemical. So we're going to be changing grams to liters, and we're going to be changing KClO3 to O2, and we're going to need several steps to do that. Let me go ahead and record my given. 5.0 grams KClO3 liters O2. And that says liters at STP, right? So we know we're going to use 22.4 for one of our relationships. All right, now let me go ahead. Well, let's examine what our strategies are going to be here. I'm going to move that forward real quick. Oh, there we go. Wonders of technology. Here's my mole diagram. If I'm starting off with 5.0 grams, this mole diagram has been expanded from what you might be used to. Here's the part that you already know and love. Moles, mass, molecules, and volume is now, I just moved it down. So we're going to be starting off from mass, 5.0 grams. And then I'm going to be going to moles of KClO3. And then I have to change chemicals. So I'm going to need a mole ratio. Finally, I'll have moles of O2 and then liters of O2 at STP. In order to do this problem, I have to start here and I have to go across one arrow to get moles. I have to do a second arrow for my mole ratio, and I have to travel across another arrow to get liters at STP. So that's going to be 3 relationships. Each arrow on the diagram represents a relationship. So let's write them out. This relationship, to go from mass to moles, I'm going to need the molar mass. So relationship 1 mole of KClO3 equals, well, I'm going to need the molar mass. So let's take a second here and do the molar mass. K is equal to 1 atom times 39.1. Cl is equal to 1 atom times 35.5. And O is equal to 3 atoms times 16.0. When you add all that up, you get 122.6 grams per mole. 122.6 grams KClO3. That will get me from mass to moles. Now I need to do my mole KClO3 to moles of O2. I'm going to start with moles of my KClO3. Whoops. And I'm going to end with moles of my O2. An important thing to notice here is that if we're going to change chemicals, if we're going to change from this to this, we have to have moles and moles. You can either change the chemical or you can change the unit in a step, but you cannot change both in one step. So here we changed grams to moles. Here we're changing chemical to chemical. finally, my third step is going to be to go from moles of O2 to volume of O2 at STP. So that would be 1 mole of O2 equals 22.4 liters of O2. Notice that I've got moles of O2 and I've got liters of O2. Now, this is embarrassing, but I just forgot. I have to actually fill in the numbers for the second relationship, and I forgot all about it. Sorry. Here we go. Let me go ahead and do that. Let's go back to step 2 real quick. Moles of KClO3 and moles of O2, in order to get that, that number that goes here, I have to actually use the reaction coefficients. Let me back up to my original slide. The number that goes here and the number that goes here come from the coefficient in front of the chemical. So this would become 2, and this one should be 3. And if you notice, this is the only one where the number that goes with moles isn't necessarily 1. Sometimes it is, if the coefficient is 1, but sometimes it's not. So I have 2 here and I have 3 there. But look what I did down here. It's 1 mole again. Up here it's 1 mole. The relationships with moles are always 1 mole, except for the mole ratio relationship. Sometimes that is not 1. All right. I have the number, I have the unit, I have the chemical, number, unit, chemical, number, unit, chemical, number, unit, chemical, number, unit, chemical, etc. I'm ready to do my fractions. Here we go. I have one fraction for my given, 5.0 grams KClO3. That's my given. Next, I'm going to have a fraction for each one of these 3 relationships. So, first relationship, which one goes on the top, which one goes on the bottom? Well, before I try to worry about that, why don't I take my grams and move it down to the denominator right here. Now I know that 122.6 goes there, and 1 mole KClO3 goes right there. Next fraction. I'm going to get some space here. All right. Next fraction is from the second relationship. Well, which one goes on the top, which one goes on the bottom? Let's just go ahead and take the moles, KClO3, and put that down to the denominator of the next fraction. I always take the numerator down to the denominator of the next fraction. So that tells me that moles KClO3 goes on the bottom. That tells me that 3 moles O2 goes on the top. Now, last fraction. Well, which one goes on the top, which one goes on the bottom? Let's take our numerator, moles O2, put it in the denominator of the next fraction. So that tells me that 1 mole goes on the bottom and 22.4 liters of O2 goes on the top. Now that you've got your 4 fractions, now you'll be able to see what cancels. Grams cancels grams, that cancels that, moles cancels moles, KClO3 cancels KClO3. And notice that I'm crossing out, I'm canceling out on a diagonal. Up here, diagonally down to the next fraction. Up here, diagonally down to the next fraction. And all the units and all the chemicals cancel, except for liters of O2. And that's exactly what I have for my unknown. So I know I've done my canceling correctly. When I put this all in my calculator and I use that fraction function on my calculator, my final answer is going to be 1.37 liters of O2 at STP. That's a 3-step mole problem. It doesn't get any harder than that. Thanks for watching.